Hello and welcome to week 8 in statistics, where we're taking on chapter 8, where we're looking at tests and hypotheses. This is a great chapter to be on right before we go into spring break as we transition from essentially descriptive statistics, with the exception of the regressions, into the tests that we use in experiments and comparing data and significance and all of these things that are going to be relevant to your research projects. So I introduced the idea of significance, and this word, similar to many words that we use in psychology, has many meanings. So significance can refer to something that's important. It can be something that was of value. It could also be something that was important to me, specifically in terms of my experience with that thing. All the different uses of the word significance, when we use it in statistics, aptly, we're using for statistical significance. And this is sort of it's a very, very important concept within the field of psychology, while at the same time it is well established that it's not the entire story. Statistical significance is a test that simply says if something is statistically significant, then the data results that we're looking at, regardless of those data results, whether they're correlations or t-tests or any of the, ANOVAs and all that stuff that we're going to get into in the rest of this course, that our results, the data indicates that it's very unlikely that we got those results simply by chance. If something is statistically significant, something's going on. We don't necessarily know what it is. And there are factors that contribute to the determination of statistical significance that have nothing to do with those two variables. It's things like effect size, sample size, the homogeneity of your sample, your sampling method, all of which contribute to that ultimate score of significance and often draw critique against that term significance. And then even when we have rock solid information that there is a statistically significant result, we grab that other meaning of significance, meaning, is it important? Is it valuable? And sometimes it's not. So we're going to learn about statistical significance and the criteria that we use, the mathematical criteria that says the results that I got are indicating that there's something going on. There's a relationship between these variables. There's a cause-effect relationship between these variables. There's a model that's supported in this particular thing based on the mathematical statistical significance. There's lots to talk about after that. So we're going to take a look at that. So we're introduced, when we look at this, the language of social sciences and much of science, actually, is that when we are asking a particular question, first time I'm going to go through this, you have a research question. And in this case, in the course book, I said the research question is, what is the effect of a reminder app on compliance with regular blood glucose checks among teens? So I'm looking at an intervention, a treatment, the reminder app, on compliance, the regular blood glucose checks in a particular population, teens. So you can just dissect that a little bit. Now, in doing a study to explore this question, we're going to have to measure some things. We're going to have to measure, what do we mean by compliance? And that's it. We have to measure that. Then there's the presence or absence of the app, the person using the app. So we have one group, let's say, that's going to use the app, and we're going to measure compliance, and then we have one that doesn't use the app, and they measure compliance. Now, when we think about compliance, we have to, what do we mean by that? What is the operational definition of that? So we have the presence or absence of the app, and we're going to define compliance as the number of times per week the teens record their blood levels. The number of times. We're not going to call it compliance anymore. That's in the research question, but in the operational definitions, we are going to call it the number of times per week. Why am I going on and on about this? Because when we predict through our hypothesis process what we think is going to happen, we have to express those statements in terms of the operational definitions. The word compliance in this particular example will not appear anywhere except in the research question. It won't be in the hypotheses. So when we develop a hypothesis, we'll start with the alternative hypothesis. Now, the person who did this study is hopeful, and based on the preponderance of the evidence, what she researched on there, had fairly good confidence that yes, having the app will increase the number of will increase compliance. That's what she's exploring. She wants to get some data on that. So her hypothesis related to what she thinks is going to happen, which we call the alternative or experimental hypothesis, she'll say teens with the app installed on their phone will check their blood glucose levels more often than teens without the app on their phone. So notice compliance is not there. I'm just looking at the measure. Now, for every time we come up with one of those ideas that we think this is going to happen, we have to match it with another hypothesis called the null hypothesis, which means no, there's not going to be any difference whether they had the app or not. When we look at our data and we analyze it, we're going to come back to our hypothesis and check the language here. We're going to reject one of them. I'm either going to reject the null and accept the alternative, or I'm going to reject the alternative and accept the null. The philosophy behind that language and the language of the null hypothesis within science, including psychology, is that we are going to come from a standpoint, first and foremost, unless you show me evidence, I'm going to assume there's no effect. The scientific mindset is that nothing is going on. The starting point, even after you've done all that research, preponderance of the evidence, and maybe your hopes and dreams to have an article published, you want there to be effect. You think there's going to be an effect. You are pretty sure there's going to be an effect. The basic scientific principle is I'm not going to believe there is an effect until there's data that tells me otherwise. That mindset of basically show me the money before I'm going to believe you is an important mindset to have every time we study something. So all of you have projects going on right now where you think there's going to be an effect, based on the research that you did, based on the design that you're putting together. You're saying, yeah, I think there's going to be an effect here, and that's going to help you define. It helped you define your alternative hypothesis. But as a scientist, you will restrict yourself, you will discipline yourself to not believe that there's anything going on until the data says. Now you can then, at that point, you can critique how the study was done. You can continue to believe that maybe this is a false negative, all of that stuff, and what you do with that afterward. But as far as your study is concerned, null hypothesis until data says otherwise. Okay? That brings us to the concept of errors, I think. No, the concept of tails. Let me get to that page here. When we predict something is going to happen, let's say we looked at this particular. I'm going to connect this to significance now. So let's say my alternative hypothesis is that kids with the app are going to measure their blood sugar more often than kids without the app. Now, the difference between those who, it's not a zero game. It's not like the kids are not measuring their blood glucose at all, and then we add the app. It's there's levels of response rate, and we're going to be looking at the response rate of the non-app versus the response rate of the app group. And we're going to look at the difference between those. That's what we're going to be measuring. How much more do they do it over here? That's our hypothesis is pointing in a particular direction. Now, it's conceivable to think that having that app on their phones could have a negative effect. It's not it doesn't go along with with existing research or what we think would be going on. It doesn't come to mind about like, oh, that's a dangerous app. But technically, it's possible that the people who have the app probably imagine someone who, they got that app and it has a stupid little smiley face on it and everybody sees it. So I want to take that app off my phone. It has a kooky little song that it plays, whatever may contribute a negative. It may, we've predicted it's going to be more or nothing. What about less? What if it makes people measure their glucose level less? So that decision to whether you're going to consider the possibility of a negative effect of your intervention determines how you are going to measure statistical significance. As a concept, let's connect statistics here to a term you might have heard in abnormal psychology, and that is the term iatrogenics. Iatrogenics, as a field, is the study of the negative effects of treatment. So you take a drug and it affects you this way, but then there are negative effects that go this way, or you take the flu vaccine and you get sick. You don't get maybe as sick, or maybe there are, when we look at the different vaccines, there were people that were allergic to it. There were people that had rare circumstances, that made things worse. So there's this notion that we appreciate that there could be a negative impact from our intervention. It's a very open-minded scientific way to think about that. Now, if we are going to write our hypotheses to either a direction or to encompass both, there's a little bit of wording changes that happen. So in the example, it says, persons that have the app will measure their blood glucose more. That's indicating a direction. So that test is going to be what we would call a one-tailed test. So if you look at the graphic here, you're looking at the one on the left. I'm saying that it's going to measure more. So when I do my statistical test comparing those means, I'm going to be operating at, there's an arbitrary line of statistical significance called the 0.05 level, which means there's less than a 5% chance that this was just a random thing. I don't want to use the word chance again. There's 5% chance that this happened by chance, but I guess that's accurate. So there's less than 5% chance that this sample was by chance. Remember the standard curve. We're way on the tails here. But I'm only interested in one direction. So the criteria is 5%. If I'm going to count both positive and potential iatrogenic effects of my treatment, I'm going to go a two-tailed test. And that would entail a different hypothesis. My my hypothesis, my my alternative hypothesis would be individuals with the app will have different levels of, no, different numbers of use of recording their blood glucose level. When I say different, I'm saying it can go either way. Some might do more, some might do less. We're looking at the mean. So what's the average of that? You know, it might actually overall, keeping in mind we're looking at a group of people. Some people it's a big thing, and some people hated it and they just had a negative effect. But what was the average effect? And it could be negative. By doing that, by taking into consideration, I want you to know this, we take that 5% line in the sand that we talk about. There has to be a 5% or less chance of this happening by chance, and we have to divide it between both tails. So you'll see in this graphic, if I'm going to do a two-tailed test and take into consideration iatrogenic effects, I'm actually raising the bar in terms of what is going to be significant. If I just go one-tailed test, then it just has to be less than 5%. If I do a two-tailed test, it has to be less than 2.5%. You see that that's a higher criteria. It has to be that much more unlikely to have happened by chance. Now it's hard to wrap your head around that. I hope I've explained it. So you have this. If I'm gonna pick a direction, I'm actually picking an easier standard to meet, slightly. If I pick both directions, then I'm making it a little bit more tough on myself. Editorial, this is why all medications, treatments, and whatnot are done on two-tailed tests. They raise the bar as high as possible. So if a study has been done on a new medication, call it the COVID vaccine, even though that was fast-tracked, the data was compared on a two-tailed test, took into consideration the potential and actual negative effects of the vaccine. And still, it came out much more positive across the whole populations that were there. In fact, the criteria was way more than 0.05. Imagine 5% of the people getting the vaccine dying. That would be unacceptable. Whereas 0.00001%, well, that any death it's not acceptable losses, but that might be something that carries enough that we would think, okay, we need to be careful, we need to test for particular allergies, we need to do that. But by and large, this is way positive. And that's truthfully what the criteria was. So now that we know about tails, we introduce the concept of errors. Now, errors, there's two types of errors, and that is when we have a false positive. We should have rejected the alternative and accepted the null. And then we have a false negative where we accepted the null when we should have rejected it. There is a calculation that's based on sample size, level of significance, and the effect size, meaning how much of a difference do we expect there's going to be. And that calculation is what we call power. There's a little app that you can download to measure power, usually done after a study is completed, and we look at the data and we test it for power to see if our statistics were powerful enough to avoid the type 2 error. We also use that particular tool, and I'll be working with you individually on this, to determine what would be the ideal sample size based on the kinds of effects that you see in your original research, in the original article, the source article. What are you expecting in terms of effect size? So sometimes you can put effect size in there and solve for sample size. You'll put power in that. Power is defined, but then we can put effect size, and we can predict and solve for sample size. It won't matter. You're going to go with whatever you get, but it would be part of your discussion might be that your statistics they lacked sufficient power to avoid, for the most part, type 2 errors. And so that's something to discuss in your paper. It's a limitation of your study. Okay, off to the assignments here. We have Chapter 8 discussion, where I want you to have a discussion about null results. Now, the history of psychology and literature has been that most often publishers focus on alternatives, significant results. They want to focus on that. There is an ongoing dialogue about sometimes what we want to know is that there is no effect. So let's say classic experiment, classic study that was done was DARE. The whole program called DARE was introduced to reduce consumption of drugs and alcohol in teens. And when the study was done, after doing that for several years, and the data was found, is that it was found that the effects, notwithstanding that there are probably people who had their lives transformed by that program, but by and large, there was null effects. It wasn't any more effective than just the regular sort of services that were available, and that's why you don't see DARE anymore. Sometimes it's important to recognize when things don't have an effect, but those things don't always get published. So I want this discussion to focus on what would you like to see studied to make sure it's actually working. There's a lot of things going on in our political world that if we applied them to data, is this really going to have the effect that people are hoping it will? The powers that be hope it's going to be. There's a lot of things that we do in an effort to make change, and we might want to know whether I'm wasting my time or not, that kind of thing. Then we go to the quiz. Now the quiz is 10 questions, and they're listed in the course book. So what I'm asking you to do, the first couple questions here, based on the way they are written, I want you to determine if these are one-tailed or two-tailed tests. Okay, you can do that for the first 4. And then for 5, 6, 7, and 8, you are going to write both a null and alternative hypotheses. Remember, you are probably going to have to come up with the operational definitions. Just make them up. So you'll do that as well. And then for the last 2 questions, define type 1 and type 2 errors, and describe in your own words the importance of sample size and effect size related to the occurrence of type 1 and type 2 errors. So these are kind of a big quiz. Now, I can ask you to do a big quiz because the week after this one is spring break. So it's a really great segue into when we come back, we're going to start looking at the different tests that you will actually be using to compare means within your studies. In addition, I want to see some progress happening on the research projects. I am open to working with you during the break. I'm not going anywhere, no trips to Paris, not going on the shuttle, or not going on any of the space trips this year, not happening. Not that they ever did. But I'm available during this coming week to work with you on your projects, to get some of those going. Some of you, I'm hoping we can launch them on Monday when we come back. I'm thinking there's some that just It's just a survey. You got to get that into PSY Toolkit, and we'll just start putting them out next week, and you can start collecting data. Those of you who are doing experiments, what we're going to be working together to figure out how PSY Toolkit is going to help us do that. I did do a search of other tools like PSY Toolkit, and they all cost a lot of money. So this is the tool to go with, and they were just as complex to learn. There was no really good plug and play type applications for this. So we're going to be working together on that. But for right now, we're going to be looking at that discussion on null results and these 10 questions quiz that you'll be taking, and then shift it into gear toward spending some time with your research projects, even though it's spring break. I know, not quite a break, but that's the way it can be sometimes. All right, so I'll see you online this week. Have a great week and take care.